Chapter 6, B, the second half, day 5. This is a warm-up of the first 3 learning targets that we've been working on. So I'd like you to try, there are 2 questions here for graphing and then 2 more questions. So pause the video, try these questions, and then either check the answer key or the notes, I should say, to make sure you got them right, or you can, obviously you're going to have to restart the video again anyway, but then you can listen to the video explanation or skip through that depending on how well you did. So pause the video, try these 4 questions, and then check your work either through the notes or by listening to the explanation on the video. Okay, and whenever we graph an inequality, it's kind of like if we had an equal sign here, we just have to remember if it's not solved for y, like in the second example, if we multiply or divide each side by a negative, we have to flip that inequality. So we always start with the y-intercept right here, and then our slope is, there's a 1 in front, so it's -1/1. So we go down 1, but then we go to the right one. There's still a lot of mistakes. People are going negative, or down and left. Now, before we start drawing our line, if there's not an equal sign with the inequality, then we do not have a solid line, we have a dashed line. So you have to pay attention to the type of line that you draw. And then the next part is we have to shade all the solutions that are less than the line. So the line is here, and so we shade below the line. And I know sometimes that gets tricky, but just put your pencil or your hand on the line and see if you're going up or down above it. And so depending on, this is less than. And then, of course, you can always check a point to see if this point is part of your solution. Then when we plug that point in, for the x and y, it should be true, and 0 is less than 4. So we know that we've shaded it on the correct side. Now, in the second example, you have to solve this for y. So you're going to have to subtract x from each side. Then that gives us 3y is greater than -x plus 12. Remember, we always put the x part first, so it's in slope-intercept form. Y equals mx plus b. Now I need to divide each piece by 3. And remember, there's a 1 in front. So now as we simplify this, right here, we would get y. And again, I didn't multiply or divide by a negative, so I keep the inequality symbol the same. And so this would be -1/3 x plus 4. So now I again graph my y-intercept, and now my slope is down 1 and to the right 3, down 1 to the right 3. Whoops, yeah, I did go 3. So now I have to look. This again does not have an equal with it, so it will be a dashed line. Now I need to do the shading. I am going to shade all the values that are greater than the line, so I will shade above. And so now I always like to pick a point that is part of my solution. So I am going to pick like this point right here. If you pick a point that has 0 in it, that sometimes makes it easier. This is the ordered pair 0, 5. So I'm going to check that point and plug in the x and y's. So if I put in 0 for x, and 5 for y, is 15 greater than 15? And no, is 15 greater, no wonder it didn't work out, than 12. I recopied that incorrectly. And so since 15 is greater than 12, then yes, I've shaded it correctly. All right, the second 2 questions, number 3, we just covered in that last example. Whenever you're checking to see if an ordered pair is a solution, you plug in the x value for x, the y value for y, and you see if it's true. Is 4 greater than -3 plus 1 would be -2, and yes, it is, so it is a solution. I check the second point separately, because it's 2 different questions. So is 4 less than -x plus 2? And since my x is negative, I have to make sure I pay attention that this is going to end up being, is 4 less than 1 plus 2? And that is no, not true. So 4 is not less than 3. All right, last question here to review. Okay, the first thing you do for this question is you have to pick out the slope and the y-intercept. The y-intercept is right here, and it's 1, 2, 3, 4. It is -4. My slope is going a rise of 1, 2, 3, 4, a run of 2. So 4 over 2 is the same as 2. So now normally I would write the equation of line y equals 2x minus 4, mx plus b. But this is an inequality. Okay, so I have to shade. I can see that it's a solid line, so I'm going to keep that equal there. But this is shaded all above the line, so it's going to be greater than or equal to -4. All right, so that was a review of what we've covered so far. Now, today we are going to write and solve inequalities from word problems. So let's try some simple ones first. We did these earlier, like on actually like day 1 or 2, just to kind of get a feel for this. So these are some pretty simple ones. We know that Gianna has $5.75 to spend for lunch. So how much can she spend? Well, she can spend $5. She could spend $5. She could spend $5.75. She could only spend $4. Okay, so there's a whole bunch of amounts. You couldn't possibly list them all. But what we know is that how much she spends for lunch, it has to be equal to $5.75, or it has to be less than that. But we can't really have negative numbers. So really, her lunch also has to be greater than or equal to 0. She could choose to spend 0. So oftentimes we put this as a compound inequality, where we would say her lunch has to be less than or equal to $5.75, but it also has to be greater than or equal to 0. And I just noticed that I forgot to include my 5 cents there. All right, so that's all of the possible solutions. And if we graph this on a number line, which it's really not asking you to do here, but we could have the values of 5 and 6 and $4, and here would be $5.50, so $5.75 would be right here, and it can equal $5.75, but it could also be less than. And if we went all the way over, I didn't include my number line low enough, but it also could be greater than or equal to 0. So that's just something to kind of keep in mind. All right, so the next one says Steve can work no more than 15 hours per week. So the number of hours he can work could equal 15, but it also has to be less than or equal to 15. So the number of hours he works would be less than or equal to 15. And again, could he work a negative amount of hours? No. So really we should include that his hours are greater than or equal to 0. But I'm not going to worry about that part because I think that's sort of understood, okay, that you can't go past 0 for money or negative hours. I guess you could potentially, but that would be if they like paid you in advance for hours. But we're not going to get into that tricky stuff right here. And even on this first one, okay, we don't have to necessarily worry about that 0 part. Okay, so your turn. You can travel up to 35 miles per hour on Highway 3 near school. So see if you can write the inequality for what your speed could be. So your speeds could equal 35 miles per hour, but you can't travel faster than that, so it'd have to be less than or equal to 35. And again, we could go ahead and add in that it also have to be greater than or equal to 0, but we're not going to, again, be too concerned about that piece. All right, so now we're going to get into a little bit more challenging one. And this is really the focus of our lesson of like learning target I type problem. Okay, so far we've just done some simple ones. But a farmer is putting up a chain link fence around a rectangular garden plot. He has 75 feet of fence and wants the garden to be 15 feet wide. Write an inequality expressing the possible length of the garden plot. So let's just draw a picture here first. That's what a rectangle looks like. And the rectangle has a length and a width, okay? And we know that the perimeter is adding the length and the width and the length and the width together. So we know our perimeter is equal to the length plus the width plus the length plus the width. Or some of you might remember that it's really 2 times the length plus 2 times the width. Now, notice this is a key piece. It says he has 75 feet of fence. So that means the perimeter around this outside, the perimeter has to be less than or equal to 75. So in this problem, the perimeter has to be less than or equal to 75. So that's a key piece of this about the perimeter. So now let's look at the other clue. The other clue says that he wants the garden to be 15 feet wide. So we're already given the fact that this garden, the width, has to be 15. Now, some of you could probably guess and check your way through this, but again, we're kind of leading into ones that can't really be guessed and checked if we're looking at decimal answers. So we're going to kind of show you how to do this with an inequality equation. So I can now actually fill into this perimeter that my width is 15. So now I know that my perimeter is equal to my 2 times my length plus 30. So I also know that my perimeter has to be less than or equal to 75. Because that's the most fence that he has. So my perimeter right there has to be 2 times the length plus, and I'll put my 30 in that other color because that's the part that's already set. And we know that it could equal, okay, 75, or that 75 is the most that it could be. So that means that this amount right here, okay, has to be less than or equal to 75. So 75 is the greatest it could be. So sometimes that can get a little tricky, but that's what we're looking at, is this has to be the least amount. So now all we have to do is solve this. And we would solve this by subtracting 30. So that gives us 75, and I'm going to keep my inequality the same because I just subtracted, is greater than or equal to 2 times the length. Oh, sorry, not 75. When I subtract, I get 45. And then now the last thing I'm going to do is divide by 2. So my length here has to be less than or equal to 22.5. So that is the most that my length could be. It could be less than that because I wouldn't have to use up all the fence. So those are the kind of problems we're going to be doing today. Only specifically, we're going to look at more linear inequalities. So we're going to go through this one together. And then I'm going to have you try this one on your own, which is a little more challenging because you are going to have to label the X and Y differently because your numbers you can see here are a little bit bigger. We went through one like this at the beginning of the unit as well, but you can always look back to the notes to see the explanation. So it says Bianca can spend up to $15 on refreshments for her party. So the amount, I'm just going to write down here that the amount that she can spend, okay, has to be less than or equal to 15, okay? So, and I don't really want to use S and, different variables like that since I'm going to graph it on linear inequality. So I'm going to kind of, keep that in mind as I start working through this problem. I'm going to change some of these variables to X and Y. Okay, so the pizzas cost $3 each and the bottles of pop cost $1.25 each. So we know that this spending amount, how much she spends right here, comes from pizza plus the pop that she buys. And so we know when we add the pizza and pop, it has to be less than or equal to $15. Well, how much does it cost for pizza? Well, it costs $3 times the number of pizzas that you buy, and that will give you the price of all the pizza you bought. And the pop cost $1.25 times the number of bottles of pop. So if I go ahead and write this maybe a little bit more neatly, I could let variables represent, instead of writing in the number of pizzas, I could let X equal the number of pizzas that you can buy, and I could let Y equal the number of bottles of pop. So here's my X, here's my Y. Okay, that's how these are going to be represented. And so again, if I go back, then this is going to be 3 times X plus $1.25 times the number of bottles of pop you buy has to be less than or equal to 15. So I'm going to actually write this a little bit neater down below. So 3X, 3 times the number of pizzas I buy, that'll give me the price of the pizzas, plus 1.25, $1.25 times Y, the number of bottles of pop I buy, that has to be less than or equal to $15. Now, you could solve this and put it into slope-intercept form, but what's going to happen is you are actually going to get kind of a decimal number for your slope. It's not going to be easy to graph. You could change it, but remember, when we graph, another way we could graph is we could actually graph using the X and Y intercepts. So remember, our intercepts, okay, our X-intercept is the ordered pair where it crosses the X-axis here. And so the ordered pairs on this line are always our X value, but the Y is 0, okay? And our Y-intercept is on this line right here, and that is always going to be the value of Y when our X equals 0. So if you remember, what we did is we made a t-table, so to speak, with X and Y, and to find our Y-intercept, I'm actually gonna do this in a different color so that we can kind of do this combined. So when I did the intercepts, if I want to find the ordered pair right here, when Y equals 0, I'm going to put 0 into the equation for Y. So what that's going to give me, when I put 0 in for Y right here, that's going to give me 1.25 times 0 plus 3X is less than or equal to 15. So that is going to give me 3X is less than or equal to 15, or then my X is less than or equal to 5. So my X-intercept is the ordered pair five, 0. So 1, 2, 3, 4, 5. My ordered pair here is 5, and I'm going by ones. You should label, because not all of your scales can you go up by ones. Okay? So that's my X-intercept. My Y-intercept, I have to put 0 in for X. So I'm going to take this and take 3 times 0 plus 1.25 times Y, and that has to be less than or equal to 15. I know I'm kind of running out of space, but remember, this becomes 0, so when I divide by 1.25, 15 divided by 1.25 is going to give me, let me just do that really quick. 15 divided by 1.25 gives me 12. Okay, so this is 12. So now I can go up here 1, 2, 3, 4, 5, etc. 6, 7, 8, 9, 10, 11, 12. So there's 12. put a dot there. Now, it can equal these, so I can shade in those dots. It's also equal to the line, so I can actually graph this line using the intercepts, remember? Now, I know a lot of times when we did these graphs, we had, the actual, like, all four quadrants, but we don't need that because we're not going to have any negatives for money, okay, in this case, or a lot of the other things that are in application problems. So now we need to figure out, where do the solutions lie? Okay, the solutions that I just graphed are less than or equal. So this equation, all the values of x that are less than or equal to 5. So let's look at this. X has to be less than or equal to 5. So here's where x is less than or equal to 5. Okay, so you shade this part for that. Okay, then let's look at the other part. So my y right here, oh, I didn't actually fill it in, so let's go back here. When I solved this equation, it became y is less than or equal to 12. So there's where my 12 is. And so here's, I need to graph all the values where y is less than or equal to 12, which are right here. So now there's all my solutions for this inequality. So now it says give two possible solutions. So what I need to do is I need to pick out like an ordered pair in this graph area. So for example, I could buy, this ordered pair is part of the solution. That ordered pair is the ordered pair 4, 1. And remember, 4 is pizzas and 1 is pop. And so think about it. If I buy 4 bottles of pop, or sorry, 4 pizzas, that would be 4 times 3, $12. And I add that with 1 bottle of pop, which is adding another $1.25, that's going to give me 12. That's going to give me a value of $13.25. So you can see that's less than 15. So that's one combination I can use. So one possible combination is 4, 1. Another possible combination would be anywhere else. Okay, what about this ordered pair? What if I buy, that's the ordered pair, 0, 12. So that means I would buy 0 pizzas and 12 bottles of pop. So 0 times 3, I'm spending 0 on pizzas, and then 12 times 1.25 is equal to exactly $15. So if I buy 12 bottles of pop, then I can buy 0 pizzas. So that's our beginning part of inequalities. Eventually we're going to get to solve a system of linear inequalities where we'll have 2 lines with double shading, but that's coming up later. All right, so we've spent a lot of time in this video, okay? And sometimes when the videos get long, I know that that's difficult. So I am going to give you the choice right now. You could just try this one on your own and check the notes when you're ready, or you could follow along right now for one more example. Okay, you want to save at least $150 for some new basketball shoes. Okay, so the amount that you want to save has to be greater than or equal to $150. So this is how much you save. Okay, you earn $12 per hour babysitting, okay? And you earn $10 per hour working at Culver's. So that means the amount of money you can earn, so the money that you can earn comes from $12, well, let's actually go back a step, comes from babysitting plus Culver's. So when you add that together, that's the money you earn, and the money you earn right here, so all of this money earned could be the amount that you save. Okay, so that's great, but how do we put that into play? Well, how do you figure out how much you make babysitting? Like, how much would you have earned making babysitting that week or that month? Well, you would take $12 right here times the number of hours that you babysit. and then you add it with 10 times the number of hours at Culver's that you work. So again, we're going to let variables represent. So let's let x equal the number of hours babysitting that you earn. And let y equal the number of hours you work at Culver's. Okay? Oh, that's kind of messy here, isn't it? Okay, so now we can go ahead and turn this into a complete equation, okay, by taking the savings, okay, which the savings is equal to, so again, I'm going to just write this down there. The savings has to be greater than or equal to $150, and the savings comes from the babysitting hours and Culver's, so that I take $12 times the number of hours I babysit, and I add that with $10 times the number of hours I work at Culver's, and that has to be greater than or equal to $150 if I'm going to buy the shoes. Okay, so there's my equation. My x, again, is representing babysitting hours. And the y is representing Culver's hours. All right, so we got our x and y. Now we need to graph this. Again, the probably easiest way to graph these is to graph them with the x and y intercepts. So I'm going to go back here, and when we graph using the x and y intercepts, okay, remember when we're finding the x intercept, we are finding the x value when y equals 0. When we're finding the y-intercept, we are finding the value of y when x equals 0. So really you don't have to figure out necessarily which one you're finding first, but you just need to know that if you're finding the y-intercept, you are plugging 0 in for x and solving. So this just becomes 0 right here. 12 times 0. So now what I have is 10y is greater than or equal to 150. So when I divide by 10, I get y has to be greater than or equal to 10. So my intercept is 0, 10. Well, here's my y values. So it's going to be somewhere on here. It's going to be the ordered pair 0, 10. So I'm going to go up 10. So this is 1, 2, 3, 4, etc. So 5, 6, 7, 8, 9, 10. So here's where 10 is. And I put a dot there. And now I am going to do the x-intercept. So for the x-intercept, I have to put 0 in for y. So this is going to look like 12 times x plus 10 times 0 is greater than or equal to 150. Again, that 10 times 0 is just 0. So it becomes the equation or inequality of 12x is greater than or equal to 150. So now when I take 150 and divide it by 12, that gives me 12.5. So it's a decimal number, but that's okay. We can handle that. So my x values have to be greater than or equal to 12.5. So 12.50 is my ordered pair. It's going to be on the x-axis because it's the x-intercept. So again, 1, 2, 3, 4, 5, labeling this, 6, 7, 8, 9, 10. There's 10, 11, 12, 13, 12.5 would be exactly in the middle. So now I can go ahead and draw my boundary line. It does have an equal with it, so it still will be solid. And now I have to figure out which side to shade. You don't just automatically shade in this region right here. You have to look at what the inequality says. So This part of the inequality says the y values have to be greater than or equal to 10. Okay, so the y values greater than or equal to 10 would be, here's where y is greater than 10, so this is where I shade for that piece. And now let's check the other piece. The x values have to also be greater than or equal to 12.5, so that's the area I shade. And then again, when I'm giving possible solutions, I pick out an ordered pair in that solution area. So it's usually best not to pick something on the line, but you certainly could because we're not graphing it all that accurately with the intercepts. But you could pick out another ordered pair right here. And that is the ordered pair. Let's see, that was 5, 6, 7, that's 8. And that is 6. So this is the ordered pair 8, 6. Now, it looks like it's part of the solution. Okay, but let's check it out. 8 stands for the number of babysitting hours. So if I take 8 hours times the $12 I get paid, and then I add in the $10 and times the 6 hours that I worked at Culver's, is that greater than or equal to 150? And 12 times 8 plus 10 times 6, or 60, gives us 156. So $156 is greater than or equal to 150. Okay, what's another possible solution? Just pick out an ordered pair. I know that I'm in the right range. I just wanted to show you how the money and how the application works with the just simple equation. Okay, so again, another ordered pair would be over here, that if we worked 12.5 hours at babysitting and 0 hours at Culver's, we would still be exactly equal to $150 in this case. And you could plug those in to see that. So that's the end of our day 5, I believe it was, lesson.